We'll start the second presentation on the track number 1. On the stage we have Viachaslau. Big applause.
Thank you.
He will talk about AWS temporary queues for handling workloads, the Java approach. The stage is yours.
Thank you. And thank you for joining me for this presentation. And today I'll be talking about how to handle workflows using AWS temporary and simple queues in Java in ECS containers. So before we start, a couple of words about me. So I joined EPM a very long time ago. So started as junior developer, and I participated in numerous projects in finance, insurance domains, and I was building APIs using different popular and not so software like Java, Apache Camel, Node.js, Kafka, MongoDB, AWS. So I am specializing in building APIs using integration patterns and workflow processing. So today we will be speaking about workflow queues based on some sample, close to real sample, and code is available here with the QR. You can watch it in advance, and maybe you have some questions about why I am doing this stuff this way or that way. So first of all, on our agenda, I'll be presenting the case, speaking about business requirements, what we are doing, why we are doing, and showing you some demo, how it works in real world from the product perspective. Second, a little bit of theory. I'll be talking about workflows, what it is, which architectural artifacts we need to use basically to describe and communicate about workflows. Then a bit of modern stuff about coordinating workflows in distributed architectures, and especially in microservices like orchestration versus choreography. And then I'll be stopping with some topic on enterprise integration patterns. So this is well-known stuff coming from early days and still actual, still updated. And I'll be showing which abstractions to use actually by regular software developer, not by architect. Don't afraid about the word enterprise. And then I'll be talking AWS design blueprints. So if you need to build something quickly, and so what to use actually, what to start with. So what AWS suggests. And then coding fun. So we'll be talking about AWS low-level SDKs, SDK working with queues, temporary queues. And then there will be code review. If you will. So we will be having live code walkthrough with diagrams, with reasoning behind organizing our code, and how our logical concepts, our abstractions map to our code constructs. And then summary and question and answers. So if you have any question during my presentation, just raise your hand. I'll stop and answer a question or address it after. So first of all, the business case. So what are the requirements? The first question everybody asks, so when you get the story for implementation, what are requirements? High-level view. So the case is that insurance company works with brokers. We are B2B model, meaning that insurance provider actually works with brokers, other companies, and do not work with retail customers. Then the retail broker sells a medical insurance to a client and invokes company API just to submit the application and onboard the customer. So that onboarding process might be quite long in real world, up to 2 weeks. So there are certain documents will be prepared during this process, human interactions will be required, and this is really, really sensitive process because, well, in insurance world, so just insurance, well, it involves many, I would say, other stuff like history, audit trail, and this kind of things. So, and then, well, we have already our application working with some architecture, and a new requirement came that, well, onboarding process needs to be changed that a form has to be signed by the customer. This is, I would say, a theoretical case. In real world, well, insurance company or insurance broker just sell insurance, get the money, and well, you need to do minimal hustle, well, to buy a product. But still, if you combine finance with insurance, they might be the case when we need to generate a PDF form, and that form can be signed immediately within the application or mailed to the customer, and then customer signs it and mail it back. So for insurance provider, so if we speak about enterprise architecture, so we have API gateways, different services, different integration point like SFTP. So we have, of course, our storages and orchestrators. So for retail insurance broker, so they will be some UI applications for mobile, web, different channels, again, services, API gateways. So, and we integrate with our insurance provider. So so this is our current architecture. So API gateway receives requests, and then it routes to our onboarding orchestrator service, and the orchestrator service calls 10 other domain services and business services synchronously. Well, to do certain steps which business architecture suggests to us. So validate insurance application, so get additional data about existing customer, submit application, and the green one here is, well, generate the form. So, and that was given to us, and we are, as independent cross-functional product team, need to deliver everything to the production and support it in production, and they are expecting from us, well, tell us how to do it. So, right, responsibility is full on us. So then, well, we as a team collaboratively or with a solution architect as a separate person, we decided to do it like that. So consumer submit, this is future architecture, so they might be transition architecture too, but consumer submits requests and immediately get response that request is accepted. So with some certain ID, so here we have ID, return to us ID of our submission form, and then we can poll this by get some status by ID. We get the status back, and our orchestrator actually will start a workflow, will do asynchronous communication with domain services using handles. So handlers, I'm sorry, and in the queue we will be having work item, and our workflow state will be keeping in our own storage. Of course, so domain services might have their own storage, and this is actually a difference between service-oriented architecture and microservices, besides of organizational difference. So we have a kind of every service with own data storage, and we organize them based on capabilities, not by technical layers. Okay, and now we have a question. So we have this requirement to show the form online. And some of the customers comes with the form being mailed to them. So how to actually implement that? So next thing, I'll show you how it works. And so Did it start? Okay. Okay, so here we go. So first of all, we use projections. So meaning we need to have certain fields in API return. Second, we have the application submitted for us. And we got the work item as back, reply, as our response. So in response, we have payload. We use polymorphic serialization with Jackson. So we have certain fields populated by the workflow. And we also keep original request, and we use the routing sweep pattern. I'll be talking about it. And here we can trace which steps our workflow needs to follow. And we have methods to enter every step. And this is the current step we are processing. And again, so in request, we have our action. So next, so you see that our request controller receives the request and reply is required. We start in workflow. We are posting requests to the queue, and we are blocking thread for waiting for the reply. Then another thread receives the message, and actually it invokes the action handler for the step validate rules. And then next step, next message posted. And again, we receive message to enrich the application. Then next step is about submitting application. And then again, everything repeated. And important, the last step is actually post-reply back. You see this is the temporary queue URL here. And basically, reply received. So next thing there, when we do not need this reply to get immediately. So here you see that we just send the request. We do not, our client do not request immediate form, and we return that simple status, so we have accepted. So again, we start the workflow. Our controller receives that reply is not required. We post the first message as a kind of validate rules, and our workflow immediately ends. So we return result to our customer. Then customer can pull the status and see how workflow is being handled. And you see, so these different steps here, same as in original, the first presentation, the first demo. So next slide is about, okay, why we changed this communication style in our orchestrator from synchronous to asynchronous. So probably, so you heard about site reliability engineering, or you are doing site reliability engineering. Anybody knows this acronym? Site reliability engineering. Okay, very good. This comes from Google, and it's basically about establishing service layer objective for our service, and then defining service layer indicator and defining service layer agreement. So we are, as a team, monitoring certain qualities, system qualities of our software, and we tell that we commit for our availability will be 3 nines. Okay, and then our latency should not exceed, let's say, 30 seconds. So this is our service level objective. So everybody monitors it, and SRE basically says, okay, if we are breaking this SLO, functional delivery should be stopped, and every team member, all the team, should be focused on improving our SLAs. So if we have to match 3 nines, so we need to do something with our product, change the architecture to match this quality metric. So, and now this is the question. So if, what will be availability of our API if we call 10 other APIs synchronously? So it's basically multiplication of availability of our calls. And what should be availability of the downstream service that we get 3 nines? Okay, so the answer on this question is you just need, in case of 10 services, you just need to add 1 more 9. So meaning your services you call synchronously should be more reliable as your service is. And imagine for the generation of this form, you need to call 5 additional services. And if you drop them and run synchronously, so simply drop them into the architecture, okay, let's do the same stuff, business as usual, add 5 more services. So we theoretically decrease our availability and decrease our latency. So we might not be matching our SLOs, and so to increase a bit of availability, we can introduce retry logic. So meaning it's just one annotation in Spring Boot code and one library you can include. And it basically does retry logic for you, socket breaker patterns, this kind of stuff. But now, how does it affect latency? So it increases latency. And if we are still in our SLOs, it might be okay. We might not do anything at this moment. So meaning we do not need to raise complexity with asynchronous communication if our SLOs are okay. If business is happy, if business doesn't complain about any qualities of the product, so what to change, right? So next thing I would like to speak about is about workflow definition. So here we clearly spotting patterns of workflows, and well, we would like to understand how to better describe our workflows in documentation. Documentation, it's a really useful tool for communicating our ideas with the technical and non-technical stakeholders. So we basically need to understand which artifacts to create. So one thing I usually request from my stakeholders is this swim lane or flow chart diagram, business flow, process flow chart diagram. So it uses flow chart forms on the diagram, and the important thing here that it shows the actors as the lanes, and it shows steps to the right. So here is a very good example from Draw.io. You probably know about this tool. All diagrams created there here with the Draw.io. So this part, this process flow diagram comes from the business architecture world. And so even if you do not have a dedicated architect for you, it makes sense to request this diagram from someone, or draw them by yourself and keep in Confluence or Wiki, where, well, for future generation of developers and for communication with your stakeholders. And current state of business process should be captured, ideal case, with this diagram. And basically, it doesn't tell you so that we have orchestrators there and we have a couple other services there. No, it is purely about the business architecture, steps of our process, actors, and some decision points here. So variation of that is BPMN diagrams, and this is more formal, more machine-readable stuff, and create them, well, requires a little bit of skills, but benefit, there are tools, there are libraries of these diagrams, and many major companies, big companies like SAP, keep actually a whole registry of these artifacts describing every particular line of business they are dealing with. Okay, and the second important thing here is about the state diagram. So we actually need to draw it to understand, well, which states in our process we have and how to move between states. And that will be directly mapped to the code artifacts. And of course, the formal definition of workflow, that workflow, let me read it to be precise. Workflow constitutes a sequence of outlined steps involved from the start through the end of a working process to accomplish a task. So immediately after definition, we are extracting our abstractions, we are building our dictionary, and basically we know after that how to name our classes, at least a bit of high level. Okay, then we have the orchestrator, right? So, and when we talk about orchestrator and coordinating some processes among different services in distributed architecture, so this is one dimension of this world. It's about coordination. So, how we do coordination. Either we use a dedicated orchestrator, or we use choreography when a kind of every service just posts the message to the queue, and then next service will step in to process this message. So here on this diagram, I do not depict the queues themselves, so I just use these dotted lines to indicate this is asynchronous communication. This really simplifies diagrams, and we don't need to use this queue artifacts here. So with and the second dimension here is about consistency. So is it atomic consistency or eventual consistency? And that requirement comes from our business requirements, our core architectural requirements. So, and in distributed world, if you see atomic consistency, so that's a scary flag. So basically, because you see storages belong to every service, so it's better to come with eventual consistency if you can relax a bit this requirement. This is suggestion. And communication style, synchronous versus asynchronous here. Okay, then you might ask when to use what? What is better, right? So what is the silver bullet I always should follow with? So the answer is it depends. It depends on your concrete situation, and it depends on your architectural significant requirements or core architectural requirements. So basically, complexity comes with unhappy paths. You see, if failure happens when we call the last service synchronously here, so it means we need to do compensate transaction with every other service, and we need to send fail response to the customer which is waiting, and customer needs to retry this whole operation, right? So with this style of communication, okay, if a failure happens in processing the last message, so we basically need to submit compensate messages, a kind of restock this item, or I don't know, change status of the order. So it seems a bit of simpler, this one, but in reality, this one is harder to do than that one. And it really depends on the size of workflow, and it really depends on scalability requirement you might have. If you have, let's say, relaxed latency requirements, if your customer can wait on the web page screen with waiting indicator, and you can do the synchronous orchestration as a simplest thing, and then you can return the failure code, and customer should retry. So that's about choosing orchestration versus choreography as a coordination here dimension, and you also need to think about consistency, and you need to think about communication styles. So next thing to do is about enterprise integration patterns, what to use basically. So okay, we decided we will change our synchronous communication to a synchronous one, and so here we immediately get the implementation concerns, right? So we need to use common glossary, we need to understand what abstractions to use in the code, how to name them, we need to assign responsibility on the classes, so we do the top-down design approach. So here I suggest to check this enterprise integration pattern, and we will be using here router, message, message queue, dead letter queue, routing sleep, request, reply, work item, versioning, and audit trail. So every pattern is described there. And so router, obviously, we need to decide which queue message to go, right? Then messages are our basic abstraction of data. So message queue is clear. Dead letter queue, always use dead letter queues. So, and I'll be talking about how to handle messages from this. Dead letter queues, routing sleep, this is interesting thing. When we define workflow, it can be changed in the future, right? So routing sleep basically tells you which steps should be followed to process this message. And if in the future we add one more step, so the older messages which might be stuck in the queue still will be processed. So this is a very important moment. Request reply, basically it is to connect synchronous and asynchronous world. Remember the first presentation, there I changed the projection and I requested our API to return immediate response, so I didn't change any code. So for that, I just used request reply basically to wait for the response for the workflow to stop processing. Work items, this is an important thing with workflows. So this is the item coming from step to step. So it has to be one item per workflow. So do not expect that step generates a kind of different type of structure. So, and versioning, of course, we need to version our structures, our data coming into the queues for obvious matter. And audit trail, this is an important thing in insurance and in finance domains. Basically, when we look at the message, I don't know, in some dead letter queue, on some UI, in database, we need to understand what was the previous steps. What was the previous state of this work item? That to keep all the context within the message. So next thing is about, well, some additional concerns and principles to follow when we start talking about workflow. First of all, which naming to use? Should I use event, message, comment, action, or work item? So you have whole dictionary and whole buzzwords you see through your career. And the important answers here, what's the difference between, the important question, what's the difference between event and message? Anybody knows? Okay, the difference is two. Message always has recipient to get this. Event is just, okay, something happened. You might ignore me, but I don't know who is concerned about this event. So we stick with the word in message. And then how many queues for workflows? So this is not an easy question to answer. So it might be fast and slow processing steps. Well, I would say consider velocity. So if your step is slow processing, slow queue processing, or fast queue processing, and basically rule of thumb, 1 queue per unit of work. So every step we can consider as a unit of work which can be processed fully or failed, reprocessed again. And then the next thing is about, well, we need to code at least one delivery when we go with the synchronous approach. So meaning that if we get the same message twice, the state of our processing of our workflow should not be changed. The outcome of processing of this message again should be the same. State doesn't change. And idempotency is meaning that we call again, and we can call multiple times the same step with the same data. And of course, concept of unit of work, all or nothing. So we do all action in this step or do nothing, keeping our state consistent as it was before, or committing the state, meaning that next consistent state will be after this step. So of course we need to think about storage, because we said, okay, we will return ID, and then our UI application will poll us and ask for the workflow status. Retry, rollback, compensation transactions should also be in the picture. And the also important question, how to handle basically messages in that letter queue. So, and Also very popular question among developers, well, let's introduce our schema checking of our messages and our queues. So every dependency we bring into picture increases artificial complexity of our solution. So there is a semantic complexity which comes to us as a business requirement. Semantic complexity, well, we can descope, we can discuss with our stakeholders, well, why do you need that? It's hard, it's expensive to implement, let's descope it. I suggest to descope it. So if your business users are kind of flexible in requirements, they rethink and might descope something, then you decrease semantical complexity. So and decreasing artificial complexity is in your hands, not to introducing elements, additional elements in your architecture. So for schema checking, if you have really complex workflows, many queues, many teams working on that, Avro makes sense. It's just a contract. If you do not have that, simpler techniques exist just to soften your schema requirements. And of course, for these enterprise integration patterns, so you have older implementation, Red Hat, JBoss, Fuse, based on OSGI container, and Apache Camel. I personally spent maybe 2 years of my professional career working with this thing, with this beast. I didn't like it. So, and Spring integration. So, certain pros and cons, but problems there, if things get bigger, it's well, really hard to manage them through these UIs, debuggers, XML definitions of workflows. So this becomes really hard and makes developers unhappy. So it's harder to find people for these things. Then, okay, AWS design blueprints for the workflows. So here I have 10 minutes left, so I need to be a little bit quicker. Managed solution. API gateway can call step functions synchronously or asynchronously. You can have express workflows. For step functions, you need to define state machine in state machine language, JSON-based, or on UI. And there is a library of workflows for different use cases. You can see samples, real samples, how to start with. And plus here that you can call bunch of our services, of other services, Lambdas, ECS, through the HTTP, through the task. Then you get work item out of your step functions workflow, process the item, get the result back. It has human interaction, of course SQS, of course direct posting to DynamoDB. So with small or medium-sized workflows, I really suggest to check AWS Blueprints. We will be building this one. Less services in use, all existing services we add only SQS as an additional processing unit here. So just calculating boxes, this looks simpler. Well, it might fit our use case again. So fits to our requirement. This is system architecture, right? So can you tell which one is good or which one is bad? Yes, exactly. I don't know. I don't know. I cannot tell this is good, this is bad. I can tell this is satisfy our architectural significant requirement. This does not satisfy to our architectural requirement because of complexity, budget costs, because of constraints with skills of our people, whatever is there. So on my case, for my architecture, for my ASRs, I choose this one. And it's simpler, right? And we can do it quicker. Time is always constrained for us. Okay, so temporary queues. Okay, one thing we need to use is a temporary queues. AWS API Gateway kind of gives us as a built-in feature. So this is request reply pattern, and it's based on correlation ID. So when producer produces a message, so it generates the correlation ID. It creates temporary queue for AWS. It uses also virtual queues there, and it sets as an attribute of the message the queue URL it expects the result back. Then you see here it blocks the thread. It waits. post message to our normal request queue, consumer consumes it, and uses this reply queue basically to post message back, temporary queue. Then our producers unlock the thread and returns the request back. And you might ask, what's the catch here? So, or I might ask, what's the catch here? So the tricky question. So the problem in this approach, anyone spots it? What happens if timeout, if the blocking thread times out? What happens with the workflow? So that's the first question to ask here. Answer to this question, well, think about it. I know the answer. You can, well, ask me in email, but that is homework if you are interested in this stuff. Okay, so now, 10 minutes left, we are coming to our code. So after we know what, why, after we know our basic logical concepts, after we know system architecture, so we can relax, sit, and do the simplest stuff, right? Design our solution, design our packages, design our classes, and use a couple of dependencies basically to do our work. Okay, so here, I love this stuff. This comes from Java, IntelliJ Java Enterprise Edition, UML classes diagram. I like it in the simplest forms because it gives me middle-level view of this. So first of all, we identified, we have request message. Request message actually included into reply message. Reply message can give us error. So we need to keep context, user information, user profile. And every request message basically has a routing sweep, meaning the steps it needs to follow through the workflow processing. And routing step basically commands us which delivery method we use and which message queue we need to post. And of course, our routing step knows about workflow. It's basically defined. Okay, with this method, we come to this workflow state, and we need to use this queue. And then action handler, it's basically about workflow action. This is work item, right? This is our onboarding application. We simply passed from step to step, and every step adds their input to this workflow action. This is interface. Workflow step is this is interface, and we actually, I'll show you after. We actually organized our classes and packages interesting ways that to separate actually core from the implementation. Very simple thing. Router, of course, we need to know basically which message to push, which queue to push this message, and from which queue to consume this message. And of course, we have a separate concept of workflow, which knows about workflow action, and which can trigger our processing and basically define the routing sweep. And so here. Any questions so far, by the way, while I'm opening this? No? Okay. So imagine you get this code as a PR, right, for review. Okay, so here, like I said, we have message. So this is a separate package. This is a low-level message. Here we have the important thing here is so we keep organizing our stuff based on features, not based on technical capabilities. So models is not a separate package; it's a package inside message, meaning this model is only for message. And so here, request message. Okay, so basically. It keeps workflow action, and it keeps routing sweep, it keeps the context, everything you saw on the diagram. So, and workflow action, it's basically interface. So it uses polymorphic serialization with Jackson. So meaning we will be defining exact workflow. So it has router. So router basically can do basic things, right? Handle, post, reply, route, send. So very simple. And of course, we have reply message and And then we are coming to the workflow, right? Here, we try to separate what belongs to workflow. So first of all, workflow basically operates with the action. It knows about a router, and it knows how to start workflow, right? And it should define the route and sleep. So this is the responsibilities of workflow. So anything else, well, we hardly can imagine, right? So, and it's a core class. I usually don't like building deeper hierarchies in OOP because, well, we have different styles, functional styles, this kind of thing. So maximum two layers deep. And I prefer to use, composition over this deep inheritance. So here, okay, action handler. This thing is also simple. So it handles workflow, specific workflow action or work item, and it knows about the state, right? And then what it does, it basically accepts the request, takes the action out of this request message, and calls the handle message. So you see abstraction here, it tells you, well, look, if you need to implement specific step of workflow, care about the handle message. Here for you the action, and just process it and return the result. Don't care about the other stuff. And it's still possible to customize the routing sleep because we have control over the request message, right? So next thing here is about model. So just workflow action, nothing is here, and workflow state, nothing is here. So interesting stuff comes here when we have the onboarding, right? So onboarding, this is actually our real workflow. So, and what we need to define to define our workflow. First of all, so we need actually to have our workflow instance. And you see it is not a bin, or it is a bin, but it is a prototype bin, right? So anybody worked with prototype bins? Okay, really cool. And actually, so this is really useful stuff. It means that, okay, we need to create instance of this bin every time we access it, right? So in controller, you see, this is, by the way, Spring, coming from Spring object provider. And this is a kind of Spring generates for us factory, right? So, and here, when we need to create our workflow with certain parameters we receive from request, so we just pass this parameter and boom, we get the workflow instance, right? And here comes another question. Does the Spring controls destroying of this prototype bin? No? Anybody knows? So for singleton, I can do on destroy, right? But for prototype bins, can I do that? So the answer is no, because I created it, so I control the lifetime of this bin. So here I just created the workflow instance, passed the parameters, and our onboarding workflow basically mutates the routing sleep based on parameter it receives, right? So it could be request wait reply, or it could be simply post, and that's it. So, and other thing, so the model, so this is our onboarding action. This is specific our onboard data specific for our onboarding. So you see here validation response. You see here enrichment response, submit response, and there will be one more thing. PDF form will be added there. So then we have the onboarding application. So basically, this is application, and this is workflow work item. So it contains application and other things we add through our steps. It has also interesting thing that here we have enum, right? So extending our message queue. So we usually use one queue here, inbound queue. We can use many queues. We can modify this workflow after and define many queues from which we should listen for items. And basically, we define our states, right? And next thing, so we have handlers for every step. And our handle method is a pure function. So it means that we do not mutate original action. We just create a copy. And Lombok is very useful here. And we also add additional data and return the new action there. So we have business rules handler, we have enrich application handler, and we have the submit application handler. Right. So this is briefly the review of the code. And here, that should be a demo how I added a new step in workflow. I'll post this presentation on this GitHub. You'll watch it later. But believe me, this is very easy to do. And also question, OK, what if we forgot to define the handler for our step? What happens with our item in our queue? So no handler to process this step, how it behaves for the negative path. So, and here, summary. So, what we have just learned. Message queues meant to be used for fire and forget communications. So, this is primary usage of message queues. So, this kind of request reply and using temporary queues, this is advanced things complicating your solution. Always stick to the simplest one. And the message queues is about, sorry, I should do this presentation. OK, so, and message queues can be very easily handled through the SQS listener annotation in Spring. You still can have these abstractions of the data in your queue. So this request message, reply message, and all this work item stuff, handlers. But instead, well, you use just one style of communication. So request reply might look like a request response, but it's not. So it's much more complex. Then, well, we need to explore every AWS managed services before diving into our custom solution because of complexity. So probably we need to do more coding for Java and SQS. You solve this abstraction stuff. So we discussed, and from maintenance concerns, it's always easy to go with managed services than, well, to have this burden of monitoring your workflows by yourself, keeping state of your workflow. So, and second item is about, well, always look around searching for patterns and blueprints. So integration patterns, well-developed topic. Many enterprises or all enterprises are doing that. Look into the patterns to get you insights about how to be with your own abstraction. And so next item, AWS step functions. Very cool in handling workflows, many cases. Integrations with many major AWS services. So even with ECS, it can fire the task in ECS. It can call the HTTP endpoint in ECS. So really consider before going in with your own implementation. And there are other solutions for workflow orchestration. Kamuda, BPMN notation. So you can draw your workflow in BPMN, drop into Kamuda, and it will execute this. Uber Cadence, Netflix Conductor. So, and here comes the next item, the last one. So, which one to use? Which one is better? It depends on scale. Simpler workflows, more complex workflows, and of course, size of the company, size of the business processes you are handling. Imagine Uber created Cadence and Netflix created Conductor for their use case. It doesn't mean immediately we need to bring this dependency in our site if we can stay with the simplest, even old solution. And that's probably it. So we are almost on time. And OK, if we stay a minute or two, so I have slot for questions. Nope, nothing? OK. If you have any questions after, so drop me a message. You can find me on LinkedIn. And thank you for your attention.